gonna discuss about the simple cubic crystal system for if we want to build up a relationship between dA and R. dA and R, where R is the radius of the lattice point or atom or one ion whatever, and A is the length of the unit cell, as well as we can say that A is the cell constant, R is the radius. So right here R is the radius of lattice point, radius of lattice point, and A is the length of unit cell you can see here this, if you consider this is a unit cell. Okay, so here is the length of the unit cell or edge length, or you consider edge length of the unit cell, that is the E. Okay, so here E is the length of unit cell, or we can say that this is the cell constant or cell constant, that is A cell constant, or that is a cell, that is also the cell parameter, also known as cell parameter, lattice constant, or lattice parameter, etc. Okay, and D is the nearest neighboring distance. D is the nearest neighboring distance, you all know that, or you can say that this is the interionic distance. Okay, interionic distance or distance of closest approach or nearest atom to atom contact. Okay, so I'm gonna discuss about the relationship between D, A and R of the simple cubic system. So if you notice here, these are the atoms, these are the lattice point of a unit cell. This is, if you consider this is a cube, then there are 8 lattice points, and here in this 8 corners there are 8 atoms, right? So here if we consider this is a square, if we consider this square, this is the right face of a cube, and it's the left face of a cube, it is the top face of a cube, and this is a bottom face of a cube. So if we consider this right face here, so you can see here that there are 4 corners, right? There are 4 lattice point or 4 corners here, and if we consider these atoms are here like this, so the radius of these atoms are R, and as well as here is also the radius of this circle or atom. If you consider this is atom, I'm writing here atom. Okay, so this is also R, the radius of the atom is R and R, and you can say that this is, we have also written here that this is the edge length, okay, or unit cell length of unit cell length of a unit cell, or edge length of a unit cell, whatever you can say. So this is denoted as A. Okay, so we can write A is equal to, there is R and R here. Okay, so we can write that R plus R equals to A, right? So R plus R equals to A, that is we can write here 2R equals to A. So, or here you can see that the length of unit cell is A, right? Length of unit cell in a simple cubic crystal system, unit cell is equals to A, and D is the interionic distance, right? Interionic distance. So here we can say that here A equals to D for HCC, right? So if we write that A equals to D, then also from, if we write that this is the equation number 1 and this is the equation number 2, from equation number 1 we can write that 2R equals to D. Okay, so I equals to M. we get the uh, equation, that is for SCC. 2R equals to D equals to A. A is D is the interionic distance, and A is the length of the unit cell, and R is the radius of the lattice point or atom or ion. We have considered here this is the atom, so the radius of the atom is R here. Okay, so 2R equals to D equals to A. Or you can write that D equals to R by 2 or A equals to R by 2. Basically this is important, so we're considering this A, that is the cell constant or the cell parameter or length of the unit cell, that is equals to R by 2, radius of the atom, that is by 2. Okay, we get this equation from the simple cubic crystal system. Okay, that's it.